I am Radhakrishna, mathematics teacher. Today we are going to discuss the next method of integration, that is integration by successive reduction. Let us first observe few important models. How to find integral sine cube x. Integral sine cube x can be evaluated by substitution method. First you write sine cube x as sine square x into sine x. You separate one sine x. Sine square x into sine x. And this sine x is the derivative of minus cos x. And we can write sine square x as 1 minus cos square x. Then by putting cos x is equal to t, we can integrate by substitution. Writing sine square x as 1 minus cos square x into sine x dx. Then putting cos x is equal to t. Derivative of cos x is minus sine x dx is equal to dt. Then sine x dx will be minus dt. We get integral 1 minus t square into this is minus dt. Then integral of 1 is t, integral of t square is t cube by 3. So we get minus of t minus t cube by 3 plus c. And now substitute t is equal to cos x. Minus of minus is plus, second term is plus, so I will write cos cube x by 3 minus cos x plus c. This is the method of finding the integral of sine cube x by substitution method. Now let us observe one more example. How to find integral cos power 4x, or it can be sine power 4x. Here when the power is odd, you write it as cos square x whole cube, whole square, cos square x whole square dx. We can write cos square x as 1 plus cos 2x by 2. Whole square. Now by expanding, we get, take 1 by 4 common, 1 by 4 into integral, expansion of 1 plus cos 2x whole square is 1 plus 2 cos 2x plus cos square 2x dx. We can integrate 1, we can integrate 2 cos 2x, but for integrating cos square 2x, we should write this as 1 plus cos 4x by 2. 1 by 4 integral 1 plus 2 cos 2x plus cos square 2x is 1 plus cos 4x by 2. Then 1 plus 1 by 2 is 3 by 2, 3 by 2 plus 2 cos 2x plus cos 4x by 2. dx. Now we can integrate each and every term. Integral of 3 by 2 is 3x by 2, 1 by 4 into 3x by 2 plus integral of 2 cos 2x is 2 into sin 2x by 2, that will be sin 2x, plus integral of cos 4x is sin 4x by 4, another 2 is there, so it will be sin 4x by 8. You observe the previous question and this question. In the previous question, when the power is odd, we have separated one sin x and converted the remaining into cos x. Okay. And when the power is even, we have completely written it in terms of multiple angles, like this, sin 2x in terms of cos 2x and cos 4x, and then integrated. For different powers of sin x and cos x, we are following different methods. Instead of that, let us generalize the procedure and find the general integral of sin power nx and cos power nx. That method is called reduction method, integration by successive reduction. Let us take up the reduction formula 1. If you denote integral sin power nx dx by in, then we can prove that it is equal to in is equal to minus sin power n minus 1x cos x by n plus n minus 1 by n into in minus 2. How to prove it? In this general problem, we follow integration by parts, though it is a function containing only trigonometric terms. Integral sin power nx dx. In order to integrate it by parts, we separate one sin x. It is sin power n minus 1x into sin x dx. Now, taking sin power n minus 1x as first function and sin x as second function, integrate by parts. We get first function into integral of the second. What is the integral of sin x? Minus cos x. So, if you multiply by minus cos x, you will get minus of sin power n minus 1x into cos x minus integral derivative of the first function. It is n minus 1 into sin power n minus 2x into derivative of sin x cos x into integral of second function, that is minus cos x into minus cos x. Okay. Now, write the first term as it is. Now, minus of minus is plus integral. You write n minus 1 outside the integral. N minus 1 integral sin power n minus 2x into what is the remaining? Cos square x. Convert cos into sin. Write cos square x as 1 minus sin square x. Okay. Now, if you multiply by sin power n minus 2x inside, you will get minus sin power n minus 1x into cos x plus n minus 1 into integral sine power n minus 2x into 1 dx. If this is in, then this will be in minus 2. So, n minus 1 into in minus 2 minus n minus 1 into again sine power n minus 2x into sine square x. It will be sine power nx. Integral sine power nx dx is in. Then you have in the LHS, taking n minus of n minus 1 in into left hand side, what will you get? In plus n minus 1 in, that will be nin. Nin is equal to minus sine power n minus 1x cos x plus n minus 1 into in minus 2. Now, dividing by n, we get in is equal to sine power n minus sine power n minus 1x cos x by n plus n minus 1 by n into in minus 2. Okay. Now, let us solve one question by applying this formula. See, in this method, by applying this formula, in will be reduced to in minus 2. So, n gets reduced to n minus 2. Again, for in minus 2, apply the same formula. So, we are going to reduce the value of n by 2 in each step. In every step, when you apply this formula, n will be reduced to n minus 2. Okay. So, in this way, step by step you will be reducing by 2. So, finally, what happens? Suppose n is 9. In the first step, you will reduce it to 7. 7 becomes 5. 5 becomes 3. 3 becomes 1. Finally, you will get I1 as the last term. What is the value of I1? If n is 1, integral sine power 1x is minus cos x. You can finish it. Suppose n is even, for example, n is 8, then by applying this formula, 8 will be reduced to 6. Again applying the formula, 6 will become 4, 4 becomes 2, 2 becomes 0. So, finally, you will get I naught. What is the value of I naught? If n is 0, I naught is integral sine power 0x. It is integral 1 dx, that is x. So, in this reduction formula, last term will be either I1 or I naught. If you get I1, it is minus cos x. If you get I naught, it is x. Integral 1 dx is x. Okay. Now, let us solve one question. Integral sine power 6x. We can denote it by I6. Apply that formula. What is that formula? Minus sine power n minus 1x into cos x by n plus n minus 1 by n into in minus 2. N is 6. So, you will get minus sine power n minus 1, 5 sine power 5 minus sine power 5x into cos x by 6 plus n minus 1 by n, that is 5 by 6 into n minus 2 will be 4, 6 becomes 4. Okay. Now, apply the same formula for I4. It will be minus sine power 5x cos x by 6 plus 5 by 6 into, if you take n is equal to 4 in the previous formula, previous reduction formula, you will get minus sine cube x cos x by 4 plus n minus 1 by n. N is 4. n minus 1 by n is 3 by 4 into I4 becomes I2. Again use the same formula for I2. First term is minus sine power 5x into cos x by 6. Next plus into minus is minus 5 by 6 into 4, 24 sine cube x into cos x plus into plus plus 5 by 6 into 3 by 4 will be 5 by how much 8, 5 by 8 into I2. Use the formula for I2, taking n is equal to 2, you will get minus sin x cos x by 2 plus n minus 1 by n. N minus 1 by n is 1 by 2 into I2 becomes I naught. What is the value of I naught? X. So, final answer will be minus sin power 5x cos x by 6 minus 5 by 24 sin cube x cos x. Next is again minus 5 by 8 into 1 by 2, 5 by 16 into sin x cos x. Next is 5 by 8 into 1 by 2, 5 by 16 into I naught is x. In the final step we write plus c. This is the method of integration by integration by reduction. Okay. Now, let us take the second reduction formula. If In is equal to integral cos power nx dx, then its reduction formula is In is equal to cos power n minus 1x sin x by n plus n minus 1 by n into In minus 2. You can prove it in the same method. I do not want to prove this. Same method. You separate 1 cos x, it becomes cos power n minus 1x into cos x. Take this as first function and this as second function, integrate by parts. You will get the same steps, similar steps. Finally, you get the reduction formula like this. In this method also, n will be reduced to n minus 2. So, you are reducing the value of n by 2 in each step. So, repeatedly applying the formula, finally, you may get I1 or I naught. If n is odd, you will get I1 in the last step. If n is even, we get I naught. We have seen in the last question, in the last example, n was 6, it is even. So, in the final step you got I naught, we wrote the value of I naught. Here I1 is integral cos power 1x, it is sin x. If you get I naught, it is integral 1 dx, that is x. Now, let us directly solve one question on this reduction formula. Integral cos power 5x dx, it is I5. Apply the formula. What is the formula? Cos power n minus 1x by n plus n minus 1 by n into In minus 2. So, cos power n minus 1 means 4x into sin x by 5 plus n minus 1 by n 4 by 5 into I5 becomes I3, reducing by 2. Again apply the same formula for I3. it becomes cos power 4x sin x by 5 plus 4 by 5 into, taking n is equal to 3 in the reduction formula, you will get cos square x by cos square x into sin x by 3 plus 2 by 3 into I3 becomes I1. Okay. What is the value of I1? It is sin x. I1 is sin x. So, it will be cos power 4x sin x by 5 plus this into this 4 by 15 into cos square x sin x plus 4 by 5 into 2 by 3, 8 by 15 into I1 is sin x, right, plus C. Okay. Now, we have seen the reduction formula for sin power nx and cos power nx. Now, the next one is tan power nx. This is reduction formula number 3. Because in every step you are reducing the value of n and calculating finally by repeatedly applying the formula, it is called reduction formula. Now, formula number 3, In is equal to integral tan power nx dx. We have to prove that it is tan power n minus 1 x by n minus 1 minus In minus 2. First, you separate tan square x and write it as tan power n minus 2x into tan square x. Tan square x can be written as secant square x minus 1. Why are we doing this? Because derivative of tan x is secant square x. So, we want to have secant square x in the integrand. Then integral tan power n minus 2x into, right, tan square x as secant square x minus 1. Okay. Now, split it into two integrals. The first integral is integral tan power n minus 2x into secant square x dx minus the second one is integral tan power n minus 2x into 1, that is I n minus 2. Integral tan power n minus 2 is I n minus 2, directly you write. Now, what is this integral? Derivative of tan x is secant square x. So, if you put tan x is equal to t, secant square x becomes, secant square x into dx becomes dt. Then it will be integral t power n minus 2 into dt. What is the integral of t power n minus 2? T power n minus 1 by n minus 1. T is tan x. So, let us write it directly. It is tan power n minus 1 x by n minus 1, integral of this, minus I n minus 2. It is proved directly in 2-3 steps. Let us solve one question on this formula. Integral tan power 6x dx, that is I6. Apply the formula. What is the formula? Tan power n minus 1x by n minus 1, that is tan power n minus 1 is 5 x by 5 minus I n minus 2, that is 6 becomes 4. Again apply the formula for I4. We get bracket begin, taking n is equal to 4 in the formula, you will get tan cube x by 3 minus I4 becomes I2. Then tan power 5x by 5 minus tan cube x by 3 minus of minus plus I2. Let us write I2. Use the same formula. If n is equal to 2, the formula becomes tan power 1x by 1 minus I2 becomes I0. What is the value of I0 in the reduction formula? If n is 0, power is 0, integral tan power 0x is integral 1 dx, that is x. If you get I1, if the power is odd, you will get I1 in the last step. What is I1? Integral tan x dx, integral tan power 1x dx. What is the integral of tan x? Log mod secant x. Okay. Now substitute I0 and then write plus c. Integral tan power 5x by 5 minus tan cube x by 3 plus tan x minus I0 is x. Finally, you write plus c. Now, if you observe the formula for tan power nx, you can directly write the answer in one step. How? First you write tan power n minus 1x by n minus 1. Then taking plus and minus signs alternately, you go on reducing this power and denominator by 2 in each step. See, 5 becomes 3, 3 becomes 1. Now, we cannot reduce the power anymore. Then the next term will be the last term. Last term will be either I0 or I1. It depends on n. If n is even, last term will be I0 if you reduce the value of n by 2 in every step. If n is odd, last term will be I1. So, you will be able to write the answer directly in one step. Now, I will show one more example. Suppose you want integral tan power 9x dx. It is I9. Will you be able to write the answer in one step? Yes. First, tan power n minus 1x by n minus 1 means tan power 8x by 8, first step. From here, take alternate signs, started with plus sign, so next time will be minus. Reduce the power and denominator by 2, you will get tan power 6x by 6. Again, next time, next sign will be plus. Subtracting 2 from 6, we get tan power 4x by 4. Next is minus. What you will get? Tan square x by 2. We cannot subtract 2 further. So, next term is going to be the last term. What is the sign? After minus we get plus. What will you get? N is odd. So, last term will be I1. What is I1? Directly write log mod secant x plus c. So, this is the direct integral of tan power 9x. Now, the next reduction formula, formula number 4, integral cot power nx dx. If In is equal to integral cot power nx dx. The reduction formula is In is equal to minus cot power n minus 1 x by n minus 1 minus In minus 2. The procedure is same as tan power nx. What will you do? Separate cot square x. You will get cot power n minus 2x into cot square x. You write that cot square x as cosecant square x minus 1. If you multiply, what is the integral of cot power n minus 2x into cosecant square x? Derivative of cot x is minus cosecant square x. So, integral of this into this will be minus cot power n minus 1x by n minus 1. Second term will be minus In minus 2. Okay. Let us solve one example on this formula. Integral cot power 7x dx. It is I7. Apply the formula. Minus cot power n minus 1 means 6x by n minus 1 minus I7 becomes I5. Again apply the formula repeatedly. Minus cot power 6x by 6 minus I5. Taking n is equal to 5 in the formula, you will get minus cot power 4x by 4 minus I5 becomes I3. Now, first is minus cot power 6x by 6 plus cot power 4x by 4 plus I3. Taking n is equal to 3 in the formula, you will get minus cot square x by 2 minus I3 becomes I1. Okay. What is I1? If this power is 1, integral cot x is log mod sin x. So, when you get I1, you will write log mod sin x. Similarly, when n is odd, you will get I naught as the last term. What is I naught? If the power is 0, it is integral cot power 0x, that is integral 1, which is x. Now, substitute I1 here, we get minus cot power 6x by 6 plus cot power 4x by 4 minus cot square x by 2 minus I1. I1 is log mod sin x. Plus c. In this case also, we can directly write the answer in one step. How? In tan power n, we started with plus sign, but in cot power nx, we start with minus sign. Same method. Write the first term minus of cot power n minus 1 x by n minus 1. From there, go on reducing the power in denominator by 2 in every step, taking alternate signs, minus plus and so on. After that, if you cannot reduce n further, write the last term I naught or I1 depending on n is even or odd. But one more thing is, for the last term, you should put the same sign as the previous term. See, sign of the last term should be changed. It should be same as the previous term. Okay. Now, let us see one example. Suppose you want integral cot power 8x dx. What is the first term? Minus, start with minus sign, minus cot power 7x by 7. Next is plus cot power, subtracting 2 from 7, you will get cot power 5x by 5. Next is minus sign, 5 becomes 3, you will get cot cube x by 3. Again subtracting 2, next is plus sign, after minus we will get cot power 1x by 1, that is cot x. We cannot reduce the power by 2 further. So, what we will do, next term is the last term. Since n is even, last term is I naught, and the sign same as previous term. So, it will be plus I naught is x plus c. So, if you can remember this shortcut, you will be able to write the integral of tan power n x and cot power n x in one step. No need of repeatedly applying the reduction formula. Now, the next reduction formula, if In is equal to integral secant power n x dx, then In is equal to secant power n minus 2x into tan x by n minus 1 plus n minus 2 by n minus 1 In minus 2. Let us first prove it. In is equal to integral secant power n x dx. First you separate secant square x, and we know that secant square x is the derivative of tan x. Separating secant square x, it becomes secant power n minus 2x into secant square x. Secant square x is the derivative of tan x, or integral of secant square x is tan x. So, we take this as second function and this as first function and integrate by parts. Integrating by parts, first function into integral of the second. Secant power n minus 2x into integral of the second is tan x minus integral derivative of the first function into integral of the second function. Derivative of the first function is n minus 2 secant power n minus 3x into derivative of secant x, we have to multiply now, into derivative of secant x is secant x tan x. Okay, into integral of the second function. Integral of the second function is tan x. So, this becomes tan square x. Now, first term as it is minus, take out this n minus 2, n minus 2 integral, this into this is secant power n minus 2x. Now, write tan square x as secant square x minus 1. Right. Now, first term is as it is minus of n minus 2 into, if you multiply this secant power n minus 2 inside, this into first term will be secant power n x, which is In. So, In, next term is minus, this into this is secant power n minus 2x, integral secant power n minus 2x is In minus 2. Okay. Now, take this n minus 2 in to LHS, left hand side. What will get? Minus of n minus 2 in becomes plus n minus 2 in. Now n minus 2 in plus in will be n minus 1 in. So the next term is n minus 1 into in is equal to secant power n minus 2x tan x minus of minus plus. This part is taken into LHS. This second term is left. Minus of minus is plus n minus 2 into in minus 2. Okay. Now dividing both sides by n minus 1, what will get? In is equal to n secant power n minus 2x tan x by n minus 1 plus n minus 2 by n minus 1 into in minus 2. So the formula is proved. Let us solve one example. First, integral secant cube x. Applying that formula, secant power n minus 2, n minus 2 means secant power 1x into tan x by n minus 1, n minus 1 is 2 plus n minus 1, n minus 2 by n minus 1 is 1 by 2 into I3 becomes I1. What is I1? If the power is 1, integral secant x is log mod secant x plus tan x. If n is even, we get I naught. I naught is always x, integral 1 dx. So here substitute I1 and get the answer. Okay, plus C. Next reduction formula, integral cosecant power n x dx. You can prove it in the same method as secant power n x. You separate cosecant square x, then integrate by parts, same steps. So finally you will get in is equal to, here you will get minus sign. You will get minus cosecant power n minus 2x into cot x by n minus 1 plus n minus 2 by n minus 1 into in minus 2. Let us solve an example. This time I have given n even, that is I4. Apply that formula. What is the formula? Minus cosecant power n minus 2x into cot x by n minus 1. Minus cosecant power n minus 2 is 2 into cot x by n minus 1, 3 plus 2 by 3, n minus 2 by n minus 1, 2 by 3 into I4 becomes I2. Again applying the formula, plus 2 by 3 into, if you take n is equal to 2 in the formula, you will get, actually in case of secant square x and cosecant square x, no need to go till I naught. Before I naught, if n is even, before I naught you will get I2. When you get I2, In case of secant, it will be integral secant square x. It is tan x. So, you will stop the procedure at I2 when you get I2, when n is even. Similarly, in case of cosecant also, I2 is equal to integral cosecant square x. What is the integral of cosecant square x? Minus cot x. So, after getting I2, do not apply the formula, directly write I2. What is I2 here? Minus cot x, integral cosecant square x plus c, that is all. Okay. So, in the previous result I wrote I0 in case of secant power nx, but I0 will never come, because before that only at I2 we will stop, right. I2 is tan x in case of secant and it is minus cot x in cosecant x. Okay, it is finished. Now, reduction formula number 7. If the integrand is in the form of x power n into e power x dx, then its integral is x power n into e power x minus n I n minus 1. Integrated by parts, taking x power n as first function, e power x as second function. Then first function into integral of the second minus integral of derivative of the first function into integral of the second, n x power n minus 1 into integral of the second e power x. Now, take out n, then directly this becomes n into I n minus 1. This is x power n e power x. So, it is proved, only one step. If you repeatedly apply the formula, then you will get the answer as e power x into, in every term you will get e power x. So, we can write e power x common, you will get x power n minus n x power n minus 1 plus n into n minus 1 x power n minus 2 and so on. So, directly starting from x power n, taking plus and minus signs alternately, you will go on differentiating it as far as possible till you get a constant. So, we can directly write the integral in one step. Okay. For example, you want integral x power 4 dx, x power 4 into e power x dx, then its direct integral is e power x into x power 4 minus its derivative 4x cube plus 12x square, next minus 24x plus 24, 24 is constant, that is all. Okay. Reduction formula number 8. In is equal to integral log x power n we can integrate by parts and get this formula in one step. Take log x whole power n as first function and 1 as second function. Integrate by parts. First function into integral of the second is x into x minus integral derivative of the first function. Derivative of the first function is n into log x power n minus 1 into derivative of log x 1 by x into integral of the second function, that is x dx. X cancels. Take out n, then remaining becomes I n minus 1, n into I n minus 1. First term is x into log x whole power n. Okay. In this case also we can write the integral of log x whole power n in one step. X will be there in every integral, so it will be x into log x power n. Starting from here, you write plus, take plus minus signs alternately and go on differentiating log x whole power n with respect to log x, till you get a constant. What is the derivative of log x whole power n with respect to log x? Here plus, next minus sign. Its derivative with respect to log x is n into log x whole power n minus 1. Next, after minus plus, derivative of this with respect to log x will be n into n minus 1 into log x whole power n minus 2, and so on till you get a constant. Example, integral log x whole cube. It is x into log x whole cube minus derivative of log x whole cube with respect to log x is 3 log x whole square. Next is plus sign. Derivative of 3 into log x whole square with respect to log x is 6 into log x. Next minus sign. Derivative of 6 log x with respect to log x is 6. So minus 6 plus c. Now reduction formula number 9. If Imn is equal to sine power integral sine power mx into cos power nx dx, then prove that Imn is equal to minus sine power m minus 1x cos power n plus 1x by m plus n plus m minus 1 by m plus n into I m minus 2 comma n. By applying this formula, you will be able to reduce only m, n remains as it is. How to prove it? Here you want to reduce m. So, let us separate one sin x from here. Write it as sine power n minus 1x into cos power nx into sin x. Now, if you observe this part, cos power nx into cosine x, you can integrate because derivative of cos x is minus sin x. What is the integral of this? Derivative of cos x is minus sin x. So, if you put cos x is equal to t, it becomes t power n into dt. Separately, if you put cos x is equal to t, minus sin x dx is equal to dt, then this becomes integral t power n into minus dt. What is it? Minus t power n plus 1 by n plus 1, where t is cos x. I will write it directly. This is the integral of cos x whole power n into sin x is known. So, we take this as second function, this as first function and integrate by parts. You will get first function into integral of the second. First function is this, integral of the second is minus cos power n plus 1 x by n plus 1 minus integral derivative of the first function m minus 1 sine power m minus 2x into derivative of sin x is cos x into integral of the second minus cos power n plus 1 x by n plus 1 dx. Now simplify. Here you can write this minus sign here outside, minus sine power n minus 1 x cos power n plus 1 x by n plus 1. Next, minus of minus is plus. Write m minus 1 by n plus 1 outside the integral. What is the remaining? Sine power n minus 2 x into cos power n plus 2 x. Okay. Now, I will explain the rest of the method and leave it, you finish it till you arrive this result, because only limited time is left. I have to solve some other problems based on the reduction formulae. Okay. So, what you will do is, now you write cos power n plus 2x as cos power n x into cos square x. Write cos square x as 1 minus sin square x. Then you will be getting here I m minus 2 comma n and I m comma n. Take I m comma n to left hand side, then calculate. Finally, you will get this answer. Okay. You finish it on your own. Now, problems. Integral secant power 5x, I think we do not need to solve, already we have done direct application of the reduction formula. If In is equal to integral tan power nx dx, find I0 plus I1 plus 2 into I2 plus I3 plus and so on I8 plus I9 plus I10. The pattern of the terms looking little odd. Let us observe the reduction formula of tan power nx. In is equal to tan power n minus 1x by n minus 1 minus In minus 2. Taking In minus 2 to left hand side, we get In plus In minus 2 is equal to tan power n minus 1x by n minus 1. Now, let us come to the present question. Let us write this in terms of pairs like In plus In minus 2. We can write I0 plus I2. It will be a pair of this form. Next, I1 plus I3. It is also a pair of this form. Next, I2 plus I4. Next, I4, I3 plus I5 till, let us write the last two terms, I7 plus I9 plus I8 plus I10. Then observe that this is same as this. this and this are same. So, applying this result, what is the value of this here? N is 2. So, it will be, this will be tan x by 1. Here n is 3. So, plus what we will get? Tan square x by 2. Next will be tan cube x by 3. And so on. In the last term, n is 10. If n is 10, it will be tan power 9x by 9. So, this is the value of I0 plus I1 plus 2 into I2 plus I3 plus and so on I8 plus I9 plus I10. Okay. Next question. If In is equal to sin x plus cos x whole power n and In is equal to a into sin x plus cos x whole power b into sin x minus cos x whole power c plus d into In minus 2, find the constants a, b, c, d. This is the question. It means we have to find the reduction formula for integral sin x plus cos x whole power n. Reduction formula means it is not a formula that you need to remember. It is a question and we are getting a relation between In and In minus 1. So, that is called a reduction formula. Actually, the first 6 reduction formulae, integral of sin power nx, cos power nx, tan power nx up to cosecant power nx, you need to remember. Rest all results are not formulae. Up to 9th result better to remember, but these are just problems. Now, to get the reduction formula, first we separate sin x plus cos x. We follow the same method as integral sin power nx, integral cos power nx. Separate sin x plus cos x. We can integrate sin x plus cos x. What is the integral? Integral of sin x is minus cos x, integral of cos x is sin x. So, integral of this is sin x minus cos x. So, taking this as first function, this as second function, integrate by parts. First function into integral of the second. What is the integral? Sin x minus cos x. Okay, minus integral derivative of the first function n minus 1 into sin x plus cos x power n minus 2 into inner derivative. Derivative of sin x plus cos x is cos x minus sin x. Into integral of the second function. What is the integral of second function? Sin x minus cos x into sin x minus cos x dx. Now, write the first term as it is. In the second term, take out n minus 1 integral sin x plus cos x whole power n minus 2 into, if you take minus common from here, it becomes minus of sin x minus cos x whole square. So, this minus can be changed to plus. What will you get here? Sin x minus cos x whole square. But we want to write this part in terms of in and in minus 2, as previous in the proofs of the previous reduction formulae. Every time in the second integral we are getting in and in minus 1, taking in to left hand side we are getting the reduction formula. So, we should write sin x minus cos x whole square in terms of sin x plus cos x whole square. How? Sin x plus cos x whole square plus sin x minus cos x whole square will be what? A plus b whole square plus a minus b whole square is 2 into a square plus b square. 2 into a square plus b square is 1. Sin square x plus cos square x is 1. So, sin x minus cos x whole square is 2 minus of sin x plus cos x whole square. So, first term is as it is. In the second term, this into sin x minus cos x whole square is 2 minus of sin x plus cos x whole square. Now, write the first term as it is plus n minus 1 into 2 into, if you multiply by this, 2 is taken outside. What is the integral of sin x plus cos x whole power n minus 1? It is in minus 1. Next is plus into minus, minus n minus 1 into integral of sin x plus cos x whole power n minus 1 n minus 2 no? Into sin x plus cos x whole square. What is it? Sin x plus cos x whole power n. Integral sin x plus cos x whole power n is in. So, it will be n minus 1 into in. Take n minus 1 into in to left hand side. What will you get? In plus n minus 1 in will be nin is equal to sin x plus cos x whole power n minus 1 into sin x minus cos x plus 2 into n minus 1 into n minus 2. Dividing both sides by n, I will directly cancel n. Dividing both sides by n, you will get this by n plus this by n. So, what are the constants? A is how much? 1 by n. B is power of sin x plus cos x, that is n minus 1. C is sin x minus cos x whole power c, that is 1, and d, what is d? This constant 2 into n minus 1 by n. Okay. We got all constants, and all of you solve this question. Find no, this is not. If In is equal to integral sin nx by cos x dx and I10 is equal to f of x plus k I8, find f of x and k. You solve and try yourself. Now, with this we have completed the discussion on all the methods of indefinite integration and solved very good problems. So, actually one revision class is required on all the methods, and otherwise the topic is finished. Okay. So, whenever we get time, we will revise indefinite integration once. Okay. So, with this I am going to close the session.